Assalamualaikum, my name is Muhammad Iqmal. I will present about the introduction. Intergranular corrosion (IGC) is a type of corrosion that occurs along the grain boundaries of metallic materials, particularly in alloys. Intergranular corrosion concentrates on the region close to grain boundaries. The alloy composition, the production process, and exposure to corrosive environment are some of the elements that contribute to intergranular corrosion susceptibility. Next, sensitization is a process where alloying elements segregate preferentially to the grain boundaries, leaving the surrounding regions depleted. In this element is frequently linked to intergranular corrosion. The longevity and dependability of metallic structure are component depend on the detection and mitigation of intergranular corrosion. Thank you.
What is intergranular corrosion? As we know, intergranular corrosion also have an other name is intergranular attack. It is a type of localization corrosion damage that is less obvious. It is a typical by prevention corrosion at grain boundary or area nearby, with a little to no attack on the grain. Corrosion that happen along a metal grain boundary particle in aluminum alloy is known as intergranular corrosion. Sensitization with also when specific phases, purification, or chemical change occurs during processes or exposed to high temperature, increase the susceptibility of grain boundary to corrosion. It is a common cause of this type of corrosion. Intergranular is a frequency observed in phases alloy when currently corrosion media are present, which caused by the alloy to lose its ductility to strength. Other names for intergranular corrosion include intercrystalline corrosion and intergranular corrosion. Intercrystalline corrosion. Intercrystalline or intergranular refer to the space between crystalline or grain boundary. Metals are frequently made by off crystal or grain with clearly defined boundary between them. According to material science, there is a boundary specifically targeted by intergranular corrosion with the material and may cause structural failure. This can be especially troublesome in alloy containing elements like carbon and chromium, as these elements can precipitation along grain boundary decrease the material ability to withstand corrosion. Next, I would like to talk about how to stop it, intergranular corrosion. One way to less susceptible to intergranular corrosion is to use low carbon stainless steel grade heat treatment by applying heat to the material interpreted at grain boundary can be reduced or eliminated, increasing the material resistant to intergranular corrosion. This is a way technical like solution handling and etching come in hand. Take care of the environment. The metal should not be exposed to corrosion conditions that encourage intergranular corrosion. To reduce the risk of corrosion, keep variables like temperature, humidity, and chemical exposure under proper control. Through the process of passive protective oxidant layer is formed on the metal surface, which can aid in preventing corrosion, including intergranular corrosion. Next, the material resistance to corrosion can be improved by applying specification treatment. Welding process welded components are frequently likely to intergranular corrosion. The susceptibility of welded joint to intergranular corrosion can be decreased by using sustainable welding, technically used as a low heat input and post-weld heat treatment. Lastly is a frequent upkeep. Use a rotate, maintain, and inspection producer to find any corrosion early on. Timeline rotation and upcoming can help the advance of intergranular corrosion and increase the reliability of mechanical parts. Business need can successfully reduce the risks related to intergranular corrosion can be undergraded the duration by dependability of metal structure and component by emulating this preventing measure. Thank you.
My name is Noriza. I will present about causes infection in prevention grade. First of all, it's caused by the composition changes different in composition, which is often by the position of chromium carbides, leading to shrinkage at the grain boundaries. is also occurred due to the loss of corrosion-resistant element in the grain, making the surrounding area loss of grain and corrosion at the affected boundary. High sensitivity also affect, for the example, metals such as stainless steel are very exposed to the high temperature during welding, and exposure to the chloride ion in the salt water can also accelerate intergranular corrosion. Next is how to prevent. Material selection is very important. That is choosing corrosion resistant materials such as 3321 and 347 stainless steel. Heat treatment is also very important by using the correct heat treatment, such as solution annealing, quenching, and precipitation strengthening. In addition, the corrosion test that is used a method to evaluate the susceptibility to corrosion between the details. And periodic maintenance and inspection is a very important here. Non-destructive material tests such as visual inspection, radiographic tests, and ultrasonic tests to detect early signs of corrosion. Lastly, for the prevention avoid corrosion is to ensure thorough cleaning and precipitation of welding during manufacturing and handling to eliminate contaminants.
Assalamualaikum and hi everyone, my name is Nur Fakiha and now I will present about an overview. Intergranular corrosion (IGC) occurs at the grain boundaries of metals and alloys due to electrochemical potential differences, often exacerbated by high temperature and welding. In austenitic stainless steel, IGC is caused by chromium carbide precipitation at temperature between 538 to 927 degrees Celsius, depleting chromium at the grain boundaries and making them susceptible to localized attacks. Preventative measures include controlling oxidation, using reducing gas and metallurgical procedures like solution annealing and stabilizing with niobium or lithium. ASTM tests such as G6704 and G11092 are used to assess susceptibility. For example, in austenitic stainless steel like type 321 and 327, connect attack is a localized form of IGC that occurs due to carbide precipitation at grain boundaries. This can be mitigated through solution annealing, reducing carbon content, and stabilizing the alloy with lithium or niobium. Testing involves exposing sample to sulfuric acid or nitric acid to evaluate resistance. Following ASTM standards like G6704. Just that. Thank you.
Thank you, Fakiha. Next, I will share about material effect by intergranular corrosion. Metal effects such as austenitic stainless steel grade 304 and 316 are prone to intergranular corrosion when used in sensitized stage. Sensitization is caused by the precipitation of chromium carbide at grain boundary in a zone adjacent to welds between 500 to 800 degrees Celsius. Application for austenitic 300 series such as tents, sinks, cutlery, and furnace, while for 200 series like dishwashers, automobile parts, and washing machine. Intergranular corrosion also attacks in ferritic stainless steel. There are some differences between ferritic stainless steel and austenitic stainless steel. Such nitrogen is poorly soluble in ferritic crystal structure. Precipitate that cause sensitization in ferritic grains include chromium carbide and chromium nitrides. Sensitization in ferritic grains occurs during cooling from higher temperature less than 1700 Fahrenheit. At this high temperature, carbides and nitrides are dissolved, and when cooled, they can precipitate at grain boundaries, result in chromium depletion. The ferrite structure extremely high diffusion rates make it possible to cool the steel quickly enough to prevent carbide and nitride precipitation at grain boundaries. Intergranular corrosion also can happen to aluminum alloys, but more common in the heat treatable 2000, 6000, and 7000 series. Intergranular corrosion can happen easily in aluminum zinc copper alloys, where the precipitated paste is the highly anodic magnesium zinc 2. We can see some of example intergranular corrosion in real life. First picture, corrosion occurs at austenitic stainless steel, while second picture, corrosion happens at pipe, and the last one, corrosion occurs at nozzle pipe.
Assalamualaikum. My name is Muhammad Fadil Alasmi bin Muhammad Fadil. Today I would like to explain about mechanism and prevention. My first point is mechanism of intergranular corrosion. Metal grain boundaries are the site of intergranular corrosion, or IGC. At this border, chromium carbide form and lower the chromium level in the surrounding area. Low chromium level causes the metal to be more prone to corrosion by preventing the production of protective oxide layer. My second point is sensitive material. Grade 3 or 4 and 316 of authentic stainless steel are particularly susceptible. Sensitization occurs between 450 Celsius and 850 Celsius, which leads to the creation of chromium carbide. Superalloy placed on nickel and aluminium may also be impacted, particularly in areas with high concentration of chloride. My third point is preventive strategy. Regulate heat treatment to steer clear of temperatures that lead to sensation. Chromium carbide are dissolved in solution annealing, which involves heating and rapidly cooling the alloy. Use 304 liter and 316 liter low carbon grade to reduce the development of carbide. My fourth point is grades of stabilized stainless steel. Niobium or titanium additions stop chromium from being depleted at grain boundaries. This element preferentially from carbide, which preserve the chromium content. My last point is advanced preventive techniques. Protective coating and post-well heat treatment, or PWHT, can further lower the incidence of IGC. To increase alloy composition and treatment technique for greater resistance, research is still good. Thank you.
Hi, my name is Herman Saman. So we're moving to last part is conclusion. Interregular corrosion IGC is a serious issue that weaken metal by attacking grain boundary, leading to safety risks and expensive maintenance. Providing IGC requires understanding its cause and using strategy like choosing corrosion-resistant material, proper heat treatment, environmental control, and regular inspection. By applying this method, industry can reduce the risk of IGC and ensure the safety and durability of metal structure and system. Thank you.